AWS Cloud Computing by following along with an AWS Certified Solutions Architect. We acknowledge and thank the official AWS documentation material which we have used to produce this educational video. Although we will try to keep all resources consumed eligible for the free tier, ensuring that you are not charged or minimizing your charges is your responsibility. To minimize charges, remember to delete all created chargeable resources after each session. For more labs, check out the link to our full playlist from the description below. This time, we will walk you through a hands-on lab on create a key pair to SSH into an EC2 instance, create an ECS cluster, create a security group for EFS file system, create an EFS file system, launch an EC2 instance that mounts the EFS file system, SSH into the EC2 instance to add content to the EFS file system, create an ECS task definition, run an ECS task and view the results, modify the content of the EFS file system, review the ECS task results, and delete all created resources. Estimated cost for doing this hands-on is no charge, as AWS ECS for EC2 launch type and EFS are free tier eligible. The prerequisite AWS skill level is that of beginner with general understanding of AWS ECS and EFS concepts. To set up a free tier eligible AWS account and a user with sufficient permissions, check out our video on Create Admin User. To begin, fire up a browser, preferably Google Chrome, and head to aws.amazon.com. Sign in to the AWS Management Console as a user with administrator credentials. This hands-on uses Amazon EFS file systems with Amazon ECS. The following hands-on helps you get started using Amazon EFS with Amazon ECS. First, we create a key pair. For Amazon ECS, a key pair is needed if you intend on using the EC2 launch type. To create a key pair, open the Amazon EC2 console. From the navigation bar, select a region for the key pair. You can select any region that's available to you, regardless of your location. However, key pairs are specific to a region. For this hands-on, I will choose the US West Oregon region. Open the EC2 console. In the navigation pane, under Network and Security, choose Key Pair. Click on Create Key Pair. Enter a name for the new key pair in the Key Pair Name field of the Create Key Pair dialog box. For file format, for use with PuTTY, choose the PPK format, the default. For use with OpenSSH, choose the PEM format. That is the one we will choose. Adding tags is optional, so let's add a tag. Click on Add Tag and enter region for key and Oregon for value. And click on Create Key Pair. The private key file is automatically downloaded by your browser. Save the private key file in a safe place. This is the only chance for you to save the private key file. If you use an SSH client on a macOS or Linux computer to connect to your Linux instance, use the shown command to set the permissions of your private key file so that only you can read it. chmod 400 mykeypair.pem, where you replace mykeypair.pem with your key file name. Next, we create an Amazon ECS cluster, and when you use the AWS Management Console to create a non-empty cluster, Amazon ECS creates an AWS Cloud Formation stack along with auto-scaling resources. Open the Amazon ECS console, click on Services, search for ECS, and click on Elastic Container Service. On the navigation bar at the top of the screen, select the US West Oregon region. In the navigation pane, choose Clusters. On the Clusters page, choose Create Cluster. For Select Cluster Template, choose EC2 Linux plus Networking, and then choose Next Step. For cluster name, enter EFS-tutorial. For provisioning model, choose On-Demand Instance. For EC2 Instance type, choose T2.micro. For number of instances, go with 1. For EC2 AMI ID, choose the Amazon Linux 2 Amazon ECS Optimized AMI. For EBS storage, leave the default setting. Scroll down some. For key pair, choose an Amazon EC2 key pair to use with your container instances for SSH access. In the networking section, configure the VPC to launch your container instances into. By default, the cluster creation wizard creates a new VPC with 2 subnets in different availability zones and a security group open to the internet on port 80. This is a basic setup that works well for an HTTP service. However, you can modify these settings by following along. Record the VPC and security group IDs you use for your cluster, as you will need to create the Amazon EFS file system in the same VPC, and allow connectivity from this ECS security group. For VPC, CIDR block, and subnet entries, go with the defaults. For security group, select the security group to attach to the container instance in your cluster. If you choose to create a new security group, you can specify a CIDR block to allow inbound traffic from. The default port of 0.0.0.0/0 is open to the internet. You can also select a single port or a range of contiguous ports to open on the container instance. In the container instance IAM role section, select the IAM role to use with your container instances. If your account has the ECS instance role that is created for you in the console first run wizard, it is selected by default. If you do not have this role in your account, it will be created for you. For CloudWatch Container Insights, deselect Enable Container Insights, as this feature won't be needed for this hands-on and to stay within the free tier. Click on Create. The console cluster creation wizard provides a simple way to create the resources that are needed by an Amazon ECS cluster by creating an AWS CloudFormation stack. It also lets you customize several common cluster configuration options. This will take a few minutes, after which you can click on View Cluster. Your EFS tutorial cluster has been created and is in active status. Let's head over to the CloudFormation console. Click on Services, search for CloudFormation. Click on CloudFormation. Locate your newly created ECS stack and click on it. Click on the Resources tab to see the list of resources that got created. Scroll down the list and click on the VPC that got created. Note the VPC CIDR block of 10.0.0.0.0/16. Edit the blank name field to My ECS VPC. And click the check mark. Head over to the ECS console, click on Services, click on ECS, Elastic Container Service, locate and click on your cluster name. Click on the ECS Instances tab to see the instance created. Click on the container instance to view the container instance. Note the status, private IP, public DNS name, and the availability zone where the ECS cluster instance got created. Click on the instance ID to visit the EC2 console browser tab and view the instance details. Note the security group ID that the ECS cluster creation wizard created and assigned to the instance. View the inbound and outbound rules. Click on the security group name. Edit the name of the security group to My ECS Container Security Group. And click on Save. Click on the Inbound Rules tab. Click on Edit Inbound Rules. Click on Add Rule. In the Type drop-down, select SSH. In the Source drop-down, select Anywhere. This is not recommended for production environments, but is okay for this hands-on. Scroll down and click on Save Rules. Thus, you have enabled SSH access for My ECS Container Security Group. Next, you create a security group for your Amazon EFS file system that allows inbound access from your container instances or EC2 instances. This security group will contain an inbound rule that references the security group you just created or referenced for your cluster in the previous step. In the EC2 console navigation pane, choose Security Groups and click on Create Security Group. Click on Create Security Group. For security group name, enter a unique name for your security group, like My EFS Security Group. For description, enter a description for your security group, like Allow EFS access to ECS Security Group. For VPC, choose the VPC that you identified earlier for your cluster, My ECS VPC. For inbound rules, Click on Add Rule. For type, choose NFS. For source, choose Custom and then enter the security group ID that you identified earlier for your cluster. Scroll down and add a new tag, key of name, and value My EFS security group, and click on Create Security Group. And My EFS security group has been created. Now you create an Amazon EFS file system. Open the Amazon Elastic File System console, click on Services, search for EFS, select it. From the region drop-down, ensure that you are in this region Oregon. In the navigation pane, click on File Systems and then click on Create File System. Click on the Customize option. Name it My EFS for ECS. Uncheck Automatic Backups. Scroll down. Go with the defaults and click on Next. On the Network Access page, choose the VPC that your container instances are hosted in, which is My ECS VPC. By default, each subnet in the specified VPC receives a mount target that uses the default security group for that VPC. It is important that your Amazon EFS file system, your Amazon ECS cluster, container instances, and tasks must all be in the same VPC. Under Mount Targets for security groups, add the security group that you created in the previous step. My EFS security group. For both availability zones, like so. Click on Next. Leave the File System Policy Editor blank and click on Next. Review your file system options and click on Create. Your file system gets created. Click on your file system and record the file system ID. In the next step, you will reference this value in your Amazon ECS Task definition. Copy the EFS file system ID and paste it in a scratchpad. Let me paste it here, like so. Next, we add content to the Amazon EFS file system. You mount the Amazon EFS file system to an Amazon EC2 instance and add content to it. This is for testing purposes in this hands-on to illustrate the persistent nature of the data. When using this feature, you would normally have your application or another method of writing data to your Amazon EFS file system. Open the Amazon EC2 console, click on Services, click on EC2. From the region drop-down, ensure that you are in this hands-ons region. Scroll down and click on Launch Instance. On the Choose an Amazon Machine Image page, select the latest Amazon Linux 2 AMI, which is free tier eligible. On the Choose an Instance Type page, Keep the default instance type of t2.micro and choose Next Configure Instance Details. On the Configure Instance Details page for network, select the VPC that you specified for your Amazon EFS file system and Amazon ECS cluster, which is my ECS VPC. For auto-assign public IP, choose Enable. Otherwise, your instances do not get public IP addresses or public DNS names. Scroll down to File Systems. Click on Add File System. Having selected your Amazon EFS file system, you can optionally change the mount location or leave the default value. Scroll down to Advanced Details. Ensure that the user data script is populated automatically with the Amazon EFS file system mounting steps. Click on Next, Add Storage. Click on Next, Add Tags. Click on Add Tag. Name, value my EC2 Instance. Click on Next, Configure Security Group. Click on Select an existing security group and select the security group created by the ECS Cluster Creation Wizard, which allows inbound HTTP and SSH access. Click on Review and Launch. Click on Launch. On the Select an existing key pair or create a new key pair dialog box, select Choose an existing key pair and choose your key pair. Select the Acknowledgement checkbox and choose Launch Instance. On the Launch Status page, choose View Instances to see the status of your instances. Initially, their status is pending. After the status changes to running, your instances will be ready for use. Refresh periodically and check the status. When they are in running status, you connect to this Amazon EC2 instance and add content to the Amazon EFS file system. In a terminal window, use the SSH command to connect to the instance. You specify the path and file name of the private key like .pem, the username for your instance, and the public DNS name for your instance. I will use the Windows PowerShell to navigate to my private key folder. In the EC2 console, select your EC2 instance and click on Connect. Copy the SSH command to your clipboard buffer. Paste it to your terminal. You may need to use Ctrl+C and hit Enter. When you see a response like the following, enter Yes, and you are connected via SSH to your EC2 instance. From your terminal window, run the df-t command to verify that the Amazon EFS file system is mounted. navigate to the directory that the Amazon EFS file system is mounted at. In my case, that is /mnt/EFS/fs1. And hit enter. Create a file called index.html. Copy this content over. Right click, Control X, Y, hit enter, check. We have created index.html. See what is in it. And we are good. We have generated content on the EFS file system. Next, we need to create a task definition. This task definition creates a data volume named EFS-HTML. The Nginx container mounts the host data volume at the Nginx root, which is /user/share/nginx/html. So open the Amazon ECS console, close out of here, click on Services, search ECS, click on Elastic Container Service. From the region drop-down, ensure that you are in this hands-ons region. In the navigation pane, choose Task Definitions. Click on Create New Task Definition. On the Select Launch Type Compatibility page, select EC2 and click on Next Step. Scroll all the way down and click on Configure via JSON. From the video description, copy this entire JSON script and paste it here, like so. In the bottom, you need to replace the EFS file system ID with your EFS file system ID, which you had saved in your Scratchpad. I had saved mine here, so I will retrieve it from here and paste it here, like so. Or you could look it up in the EFS console and click on Save. Your task definition has been created. Let us review this task definition. For task definition name, you type a name for your task definition. For task role, optionally, you can choose an IAM role that provides permissions for containers in your task to make calls to AWS APIs on your behalf. For tasks that use the EC2 launch type, these permissions are usually granted by the Amazon ECS Container Instance IAM role. For network mode, choose the Docker network mode to use for the containers in your task. The default Docker network mode is bridge. If the network mode is set to none, you can't specify port mappings in your container definitions, and the task's containers do not have external connectivity. If the network mode is set to AWS VPC, the task is allocated an elastic network interface. The host and AWS VPC network modes offer the highest networking performance for containers because they use the Amazon EC2 network stack instead of the virtualized network stack provided by the bridge mode. However, Exposed container ports are mapped directly to the corresponding host port, so you cannot take advantage of the dynamic host port mappings or run multiple instantiations of the same task on a single container instance if port mappings are used. We will just go with the default. For task execution role, for tasks that use the EC2 launch type like ours, these permissions are usually granted by the Amazon ECS Container Instance IAM role, which is specified earlier as the task role. There is no need to specify a task execution role. Scroll down, and for task size, choose a value for task memory and task CPU in virtual CPU. Supported task CPU values are between 128 CPU units and 10,240 CPU units, which is 10 virtual CPUs. Scrolling down, for each container in your task definition, you should choose Add Container and fill out each required field and any optional fields to use in your container definitions, and then choose Add to add your container to the task definition. So click on Add Container, and you see Advanced Container Configuration. Open that out and fill out for each image or each container in your container task definition. And finally, we'll click on Add. In our case, let's investigate the Nginx container. Click on Nginx, and you see what was filled out by the JSON script. If you are linking multiple containers together in a task definition, the name of one container can be entered in the links of another container to connect the containers. Images in the Docker Hub registry are available by default. You can also specify other repositories with repository URL /image:/tag. The amount of memory to present to the container. If your container attempts to exceed the memory specified here, the container is killed. The total amount of memory reserved for all containers within a task must be lower than the task memory value if one is specified. You can add a soft limit of memory to reserve for the container. When system memory is under contention, Docker attempts to keep the container memory to this soft limit, but this is optional. Port mappings allow containers to access ports on the host container instance to send or receive traffic. For task definitions that use the AWS VPC network mode, you should only specify the container port. The host port can be left blank, or it must be the same value as the container port. Let's cancel out of here since we didn't update anything. You can use constraints to place tasks based on availability zone, instance type, or custom attributes. Optionally, for service integration, to configure the parameters for app mesh integration, choose Enable App Mesh Integration. Also optionally, for log router integration, you can add a custom log routing configuration. Choose Enable Fire Lens Integration. And for type, choose the log router type to use. For image, type the image URI for your log router container. If you chose the Fluent Bit log router type, the image field pre-populates with the AWS for Fluent Bit image. Clicking on Apply creates a new log router container to the task definition named log_router. But we will disable Fire Lens integration. To define data volumes for your task, choose Add Volume. You can create either a bind mount or Docker volume or EFS. Like we did, let's cancel out of here and check our mounted volume EFS-HTML. This is what our task definition JSON script mounted. Let's cancel out of here. In the tags section, you can specify tag and value for each tag to associate with the task definition. And finally, you can click on Create. And your task definition is created successfully. Now that your Amazon EFS file system is created and there is web content for the Nginx container to serve, you can run a task using the task definition that you created. The Nginx web server serves your simple HTML page. If you update the content in your Amazon EFS file system, those changes are propagated to any containers that have also mounted that same file system. To run a task and view the results, open the Amazon ECS console. From the region drop-down, ensure that you are in this hands-ons region. Choose the cluster that you created earlier, EFS tutorial. Click on the Tasks tab and click Run New Task. Choose the EC2 launch type. For task definition, choose the EFS tutorial task definition that you created earlier. Scroll down and click on Run Task. So you get a message, created task successfully, and the task status is running. Refresh periodically and your task is running. Click on the container instance and choose the public IP address associated with that instance. In a new browser tab, paste the IP at the URL address and hit enter, and it works. If you do not see the message, make sure that the security group for your container instance allows inbound network traffic on port 80. To edit the content of the EFS file system, edit the index.html file from your connected instance's terminal. Hopefully you still have that terminal running. If not, connect to your EC2 instance as we did previously. Locate your index.html file. Open it using your text editor. Let's replace "it works" with "works updated." Like that. Control X. Key in a Y. Hit enter. Check. And we have updated the index.html file. Let us now unmount this EFS file system from this EC2 instance and get rid of this EC2 instance. So in your instance's terminal, let's navigate to the home folder. Check our file system and unmount it. You mount the file system folder and hit enter. Try it with a sudo prefix so that you are authorized to unmount the file system. Check if it has been unmounted. Yes, it has. Log out and exit. To terminate the instance, open the Amazon EC2 console. From the region drop-down, ensure the region for this hands-on is correct. In the navigation pane, choose Instances. Select the instance you wish to terminate. Click on Actions, Instance State, and Terminate. Click on Yes, Terminate when prompted for confirmation, and your instance is shutting down and will be eventually terminated. To view the updated ECS task, open the Amazon ECS console, click on Services, search for ECS, click on Elastic Container Service. In the navigation panel, click on ECS Clusters. Choose the cluster you created earlier, EFS tutorial. Click on the Tasks tab. Click on the container instance. Copy the public IP. If you have the browser window from the previous test open, you could just click on Refresh and your task has updated. Congratulations! You have successfully tested your ECS running task. When you are finished with a container instance, you can deregister it from your cluster. Following deregistration, the container instance is no longer able to accept new tasks. If you have tasks running on the container instance when you deregister it, these tasks remain running until you terminate the instance or the tasks stop through some other means. Deregistering a container instance removes the instance from the cluster, but it does not terminate the EC2 instance. So open the ECS console, click on Clusters, choose your cluster, click on the ECS Instances tab, click on the container instance and click on Deregister. If you would rather terminate the instance along with the cluster when you terminate the cluster, do not deregister the instance and hit Cancel, which is what I would do now. But before I terminate the ECS cluster, I should delete the EFS file system and its security group. So open the EFS console, click on Services, search for EFS, click on EFS, ensure you are in the region where you are doing this hands-on. From the list of file systems, choose the Amazon EFS file system that you want to delete and click on Delete. In the Delete File System dialog box, type the file system ID for the Amazon EFS file system that you want to delete and then click Confirm. And your EFS file system is being deleted. In a few minutes, your file system is successfully deleted. Next, we should delete the security group that was being used by the EFS file system since it references the EC2 security group. You can't delete a security group that is referenced by a rule in another security group in the same VPC. So, open the Amazon EC2 console. In the navigation pane, choose Security Group. Choose the security group that was being used by the EFS file system since it references the other EC2 security group. select the My EFS security group, and from the Actions drop-down, click Delete Security Group. Delete, confirm the deletion, and your EFS security group is successfully deleted. Finally, we can delete the cluster. Open the Amazon ECS console. Ensure you're in the correct region. In the navigation pane, click on Clusters. Click on the cluster you wish to delete. And click on Delete Cluster. Deleting the cluster also deletes the AWS CloudFormation Stack EC2 Container Service cluster name. Deleting this cluster cleans up the associated resources that were created with the cluster, including the auto-scaling groups, the VPCs, or load balancers. So key in Delete Me and click on Delete. And your ECS cluster is getting deleted. The entire stack is getting deleted, so it would take a few minutes. You could go to the CloudFormation console and check the status of the delete. And you see the events and the progression of the deletion. Back in the ECS console, we are almost completely done, and the entire ECS cluster has been deleted. Congratulations on a hands-on well done. Let's check on our instances. They're all terminated. If you liked following along, please click on the like thumbs up sign below this video to cheer us along. Share this video with your friends and colleagues. Subscribe to our channel AWS By Doing, and we will update you regularly with our latest and greatest offerings. Write in a comment of what you liked and how we can improve. Check out our playlist for more labs from the link in the description below. Happy cloud computing! And we will see you again in the next episode from the AWS By Doing team.